Hello everyone, welcome to another lecture of the course Digital Signal Processing. In the previous lecture, we have introduced the decimation in time fast Fourier transform, and let us now consider a small example in order to understand that algorithm better. So we are going to use the butterfly structure in order to find the 4-point DFT of x of n using the decimation in time fast Fourier transform. So the given signal here is x of n, which is 1, 2, 3, 4, which starts from n equal to 0 at 1. So now we had seen that we need to first bit reverse this entire sequence. So the initial sequence is x of 0, x of 1, x of 2 and x of 3, and the step 1 is bit reversing to get new sequence. Now the value of n when is 0, so it can be just represented by 0, 0. When the value of n, it can be represented as 0, 1 in binary. This 2 can be represented as 1, 0 in binary, and this 3 can be represented as 1, 1 in binary. Now if we bit reverse this 0, 0, we are just going to get 0 and 0 here. Again, if we bit reverse this 0, 1, we would be getting 1, 0. If we bit reverse 1, 0, then this 0 would be here and the 1 will come here. And if we bit reverse 1, 1, then we would be getting it as 1, 1 again. And if we convert them into decimal back, so it is 0, this 1, 0 is 2, this 0, 1 is 1, and this 1, 1 is 1, 1, 1 is 3. So therefore the sequence that we need to consider is x of 0, x of 2, x of 1 and x of 3. So now what we are going to consider is, as I have mentioned earlier, we are going to use the butterfly structure here. So for that, what we will do is we will just consider 4 points like this. So we have here the first point, that is x of 0, which is 1. The second point, that is x of 2, we need to consider the bit reversed order, so that is equal to 3. Then we have the third point, that is x of 1, which is equal to 2, and the last point is x of 3, which is equal to 4. And now we need to consider the 2-point DFTs for that. So what we will do is we need to consider the 2-point DFTs for this first 2 points. So that can be found by like this. And we had seen that the scaling factor here, that is the twiddle factor here, would be W2 to the power 0. Then we would be having a minus sign here, a scaling factor of 1 here and here, and therefore the value that we obtain here, that is the value that we are going to obtain here, we would be simply 1 plus 3 into W2 to the power 0. So we are going to obtain 1 plus 3 into W2 to the power 0. Now this W2 raised to 0 would be equal to 1. So what we are going to obtain is simply 1 plus 3. So the value that we are obtaining here is 1 plus 3, which is equal to 4. So this is 1 plus 3. So it is equal to 4. Similarly, the value that we are going to obtain here is 1 minus 3 into W2 to the power 0. So it would be 1 minus 3. So here what we are going to obtain is minus 2. So we are obtaining here 1 minus 3, which is equal to minus 2. Now we need to repeat the same process for the next two values. So we need to consider it like this. And again we are going to consider the 2-point DFTs. Like this. So we have a scaling factor of 1, 1, 1, and we have it minus 1 here, and the twiddle factor that we have is again W2 to the power 0. And now the value that we are going to obtain here is 2 plus 4 into W2 to the power 0, so that would be 2 plus 4, that is equal to 6. So we have it as 2 plus 4, which is equal to 6. Similarly, the value that we are going to obtain here is 2 minus 4 into W2 to the power 0, so that is 2 minus 4, so that comes out to be minus 2. So what we have here is 2 minus 4, that is equal to minus 2. So what we have done here is found the values for the first stage. So this is the stage 1. So this is the stage 1. And now using these values we need to go ahead and find the stage 2, that is the next stage with two 4-point DFTs. So now what I am going to do is I am just going to extend this line further like this. And now we are going to consider the 4-point DFT. So this first point here can be obtained by this point, that is x of 0 and x of 1. So we have it like this x of 0 as it is, and then we are going to consider this x of 1. Similarly, this point here can be again found using this x of 0 and x of 1. So this x of 1 is here as it is, and then we need to consider this point here, and we know that the scaling factors would be 1, 1, 1 and minus 1 in this butterfly structure, and the twiddle factor here would be W 4 to the power 0. So now if we need to find the value here, so that would be obtained as this value, that is 4 plus 6 into W 4 to the power 0. So it would be given as 4 plus 6 into W4 to the power 0. So W4 to the power 0 is again 1. So it is 4 plus 6. So that comes out to be 10. And this is the value of x of 0. Another point that we can find here is this point here. So that can be obtained by considering this x of 0 point. So it is 4 minus 6 into W4 to the power 0. So it is 4 minus 6. So that is equal to minus 2. So what we have here is 4 minus 6, that is equal to minus 2, and this gives us the value of x of 2. Now we are left with two more points, that is the point here and here. So for that we are going to consider these 2 points, that is -2 here and -2 here. Now in order to obtain the point here, we have this as it is, and we need to consider this point here like this. And again this, in order to obtain the point here, we need to consider this point to be added here. So we have it like this. So let me just use some different color. So it can be considered like this and here. And we know that the scaling factors are again 1, -1, 1 and here 1. Now the twiddle factor would be W4 to the power 1. And now the point here can be calculated as -2 into -2 plus -2 into W4 to the power 1. So this can be written as -2 W4 to the power 1. So now what is the value of this W4 to the power 1? So this W4 to the power 1 can be written as e to the power -j 2 pi by 4 into 1. So it comes out to be e to the power -j pi by 2, which is equal to -j. So what we have is this W4 to the power 1 is basically equal to -j, and therefore the value that we obtain here is given as -2 plus j2, which is equal to x of 1. And similarly the value that we obtain here would be -2 into -j into -1. So what we have here is -2 minus -2 into -j, which comes out to be -2 minus 2j. Which is equal to -2 minus 2j, which is equal to x of 3. And now this second part of this butterfly structure is the stage 2. Now when we are having the value of n as 4, we are getting the values in just 2 stages. That is, the number of stages for n equal to 4 are 2, and we know that this 2 can be represented as log to the base 2 of n. So this log n to the base 2 would be giving us m, which is equal to the number of stages. And another thing that we need to see is the number of stages are equal to the number of bits that are used to represent this n. So we can observe here we are just having 2 bits that are used to represent this n from 0 to 3. So therefore the number of stages are also 2. So the number of stages and the number of bits required for the representation, or in order to obtain the bit reversed order, are same. So therefore we are having 2 stages Now another things that we need to observe are the twiddle factors. So in the first stage, the twiddle factor is W2 to the power 0. So in the first stage, the twiddle factor is W2 to the power 0. So now if I represent this 2 by n1, so I can just write it as Wn1 to the power 0, and this 0 can be just represented by n1 by 2 minus 1. So what I can say is the value of this k, that is the power, will be ranging from 0 to n1 by 2 minus 1. Same thing we can observe here when we are having the stage 2, that is the twiddle factors that are considered are W4 to the power 0 and W4 to the power 1. So in stage 2, the twiddle factors that we have are W4 to the power 0 and W4 to the power 1. So the value of this k is from 0 to 1, that is we are having two values, that is 0 and 1, and we have this n1 as 4, and if we consider this n1 by 2, so it would be equal to 2, which means that the value of this k would be ranging from 0 to n1 by 2 minus 1. So this twiddle factor are also to be considered properly in order to obtain the proper values of the DFT. Now the things that we need to consider is, in the stage 1 we are considering 2-point DFT, so the value of n1 would be 2. Then in the stage 2 we are considering 4-point DFT, so the value of n1 would be equal to 4. If we have another stage, then we would be considering the 8-point DFTs, so at that point we would be considering the twiddle factor as W8 to the power k, and at that point the value of k would be ranging from 0 to 8 by 2 minus 1, that is 0 to 3. So the stage 1 would be having W2 to the power 0, stage 2 W4 to the power k, and so on. So in this lecture we considered a simple example in order to find the 4-point DFT of x of n, and we saw that the first step is to find the new sequence by considering the bit reversed order, and then when we have the bit reversed order, we first consider the 2-point DFTs, that is the stage 1, then we consider the 4-point DFTs, that is the stage 2, and at the end we obtain the DFT sequence, and the DFT sequence that we have obtained in this example is x of k equal to 10 minus 2 plus j2 minus 2 minus 2 minus j2, and this 10 is at k equal to 0. In the next lecture we would consider another example for DIT FFT using the value of n as 8. So let's stop here. Thank you.